that I want to know how long it's going to take me to go from 0 to 60 miles per hour in my car. And I know that my car has a maximum average acceleration of 3 meters per second squared. That means it changes its velocity by 3 meters per second in every second. All right, so my acceleration is 3 meters per second squared. Okay, I would like to know how long it takes me to get up to 60 miles per hour and how far I go in that time. Well, first I ought to figure out what is 60 miles per hour in meters per second. So I'm going to do a conversion. I've got 60 miles per hour, and I know that there's 1 hour in every 3,600 seconds, and I know that there are 1,609 meters for every mile. If you don't know those, you can look them up on Google. So we have 60 times 1,609 divided by 3,600, and that gives me 26.8 meters per second. Run out of space. 26.8 meters per second. So, let's catalog everything we know. I know my acceleration is 3.00 meters per second squared. I know my final velocity is 26.8 meters per second. I even know my initial velocity, although I never stated it explicitly. My initial velocity is 0. And I want to know the time it's going to take, and I want to know the distance I travel. So notice I've cataloged all the things I know and all the things I want to know. Let's group those together and make it a little smaller. Put that up in that corner. And now, let's try and figure this out. I know that V equals V naught plus AT. That I could probably solve. This is 0, the one number I recommend putting in early. And I divide both sides by A, and I get that the velocity, I get the time is the velocity divided by the acceleration. Or simply, 26.8 meters per second divided by 3.00 meters per second squared. Now I can pull out my calculator, and I get that this is 8.94 meters. Let's check our units. Meters cancels, one of the seconds cancels, and the remaining seconds flips over into the top, so this is 8.94 seconds. And I would say that's a pretty reasonable time. A really good car can accelerate from 0 to 60 in about 6 seconds. My car is not that amazing, so 9 seconds is fairly reasonable. Now, for the distance, maybe it would be a good idea to talk about, to make a graph here. So I'm looking, and I've got a velocity that's increasing like this, and the distance I'm looking for is this whole area inside here. I've got I'm talking about moving in a straight line, so I'm going to call forward or to the right positive, and I want to figure out how far do I go. I have one more piece of information now than I used to. And it turns out that all of that information will be plenty to solve the problem. So let's get this again. Copy this, go to a new page, and let's paste it. One more piece of information I now know is that t is no longer a question mark, it's 8.94 seconds. Now I know that delta x is equal to v naught t plus 1/2 a t squared. V naught is 0, so I can plug that one number in, but the rest I'm going to leave, but look, it's all set up so I can do it. Delta x is 1/2 a t squared. So I can plug in my numbers. 1/2, the acceleration is 3.00 meters per second squared. My time is 8.94 seconds squared. Second squared cancels against second squared. I'm going to be left with meters. And I get 120 meters. So it'll take me more than a football field just to accelerate from 0 to 60. So I better make sure I've got space when I do that.